Hello everyone, I am Dr. Abha Kumari. Today we are going to discuss a particular integral of higher order homogeneous linear differential equation. In the previous lecture we have discussed about the type 1 on this topic. Today we will do some problem from the type 2. The theory portion I have given in the previous lecture. So let's see this question, how to solve this question. The question is del 2z by del x2 plus del 2z by del y2 equal to cos mx into cos ny. So to solve this problem, first we have to find the complementary function, and the complementary function is, let the auxiliary equation be d square plus d dash square equals to 0, and this will give m square plus 1 equals to 0, and this imply m equal to plus minus I. Since this is of the term 0 plus minus I, that is 1 into I. Okay. So here the real part is 0 and the imaginary part is your 1. So we will write it the complementary function as CF equal to F1 y plus Ix plus F2 y minus Ix. So this will give the complementary function. Let us do the particular integral. So the particular integral is equals to cos mx into cos ny divided by d square plus d dash square, and this is equals to half. First we will use the formula of 2 cos mx into cos ny equal to cos mx plus ny and cos mx minus ny. Okay. So while using this formula, this function will become, we will multiply, divide by 2, and we also multiply by 2. So we use the formula here and we will write it as cos mx plus ny and plus cos mx minus ny divided by 2 times d square plus d dash square. Okay. Now by solving this equation we have, this is equals to half cos mx plus ny divided by d square plus d dash square. Now we are going to separate those functions, plus half cos mx minus ny divided by d square plus d dash square. Since the denominator is not equals to 0, why? Because while putting the value of d square equals to m, that is d equal to m, and d dash equals to n, we have in the denominator as 1 by m square plus n square, and this is not equals to 0. Therefore, we put mx plus ny equals to t and mx minus ny equal to s. Okay. Now this function will become, this is equals to half 1 by m square plus n square. We use the double integration of cos mx plus ny. Okay, and then we have the function of the form this way, cos t dt into dt, and we use the double integration because we have d square. Okay, so this is this one, and then plus 1 by 2 m square plus n square, double integration cos s into ds into ds. Now since the double integration is applied here, so we will integrate 1 by 1. Now this is equals to 1 by 2 1 by m square plus n square, integration of sin t dt. The cos t will give us the sin t here, so we will write as sin t, and then we have a dt, so we will write dt, plus 1 by 2 m square plus n square. Now again by integrating only this part, we will have sin s, and then this ds is here, so integration of sin s into ds. Okay. Now one more time we have to integrate, that's why this function will become 1 by 2 1 by m square plus n square minus of cos t plus minus of cos s ds. I have taken 1 by 2 m square plus n square outside because this one is common in both the terms. Now after solving this term, we have minus 1 by 2 m square plus n square bracket cos mx plus ny plus cos mx minus ny. Okay, this way. Here we have put the value of t as cos mx plus ny and s as mx minus ny. Now the required solution is therefore z equal to cf plus pi. Now we have a cf here in this order, this way is the cf, and now we have a pi of this way. So we will write our solution as f1 y plus ix, f2 y minus ix, minus 1 by 2 m square plus n square cos mx plus ny plus cos mx minus ny. Okay. So in this way we will solve the question of homogeneous linear differential equation of higher order. Now let us see some another problem. Let's see the type 3. We have done the problem in the type 2. You all make some more problem from your book. Okay, so now I am going to discuss the type 3. What are the procedure and what is the working rule? So let's see. So if in type 3 exponential case where f of ab equals to 0. In a type 1 what we have seen where the f of ab is not equals to 0, and then we directly put the value of d as the coefficient of whatever the exponential function is given, the coefficient of x we will put in the place of d. So here in the case when the f of ab equals to 0, what we do? So to evaluate 1 by f d into d dash, that is d comma d dash, okay, it is not into d comma d dash phi of ax plus by, when f of ab equal to 0, we proceed as follows. Now step 1. We differentiate f dt dash with respect to d partially. Okay, it is very important. The partially we are differentiating with respect to d, and we multiply the expression by x. We multiply the expression by x so that 1 by f dd dash phi ax plus by will become x into 1 by f dash dd dash phi ax plus by. Excuse me. Okay, so now step 2. In step 2, again we check is f dt dash equals to 0 or not. So here if f dash ab is also 0, okay, so if f dash ab is also 0, we again repeat this process and we again differentiate f dash dt dash partially with respect to d and multiply by x. So x into 1 by f dash dd dash phi x plus by will become x square 1 by f double dash dd dash phi ax plus by. Okay. So proceeding in this way, we we differentiate again and again every time, and we multiply it by x. Okay. As long as the derivative of f d dash vanishes when d equals to a and d dash equals to b. तो जब तक हमारा d और d डैश का वैल्यू हम पुट कर रहे हैं और फिर से हमें डिनोमिनेटर 0 मिलते चला जा रहा है, f डैश का भी मिल गया, f डबल डैश का, इस तरह से f ट्रिपल डैश, f फोर डैश, तो जहाँ तक भी हमें 0 मिलेगा हम इसी प्रोसेस को आगे रिपीट करते चले जाएंगे. तो हमारे स्टेप 3 क्या कहता है? इफ़ 1 बाई एफ डी टी डैश फाई एक्स प्लस बी वाई इक्वल टू एफ आर ए बी नॉट इक्वल टू 0, तो जहाँ हमें ये मिल जाएगा कि एफ ऑफ आर ए बी अब 0 के बराबर नहीं है, then we will use this one as 1 by FRAB phi AX plus BY can be evaluated by the type 2 method. Okay. So here we have to use the type 2 and we know the process of type 2. How can we solve the type 2? So in this way we can solve the type 3 problems. I hope you all understand it very well. And the next lecture we will do the problem based on the type 3. Thank you all.